This lesson, we are going to learn how to use the first principle to find the slope of tangent at a given point on the function f(x). For example number 1, the function given f(x) is a polynomial function. So what we are going to do is we're going to do expand and simplify. Step 1, we write down the first principle. Step 2, we're going to substitute the value of the x into the first principle. And what will be the value of the x? It will be the x value of the given point, which is 2 here. Step 3, we're going to find each of the y value on the side. So we know f(x) equals to x squared. So f of 2 plus h will become 2 plus h whole thing squared. That's expanded, which is 4 plus 4h plus h squared. And we also need to find what's f at 2, which is 2 squared, which is 4. Then we're going to substitute the findings into the slope of tangent. So f of 2 plus h is 4 plus 4h plus h squared minus 4 divided by h. And let's simplify them. You get 4h plus h squared divided by h. And they do have h in common in the numerator, so factor it out. And we can simplify it by dividing by the common factor h. Make sure you write down the restrictions. And now we have m equals the limit. H is approaching to 0, 4 plus h. At this time, you will see the denominator has an invisible 1 there. That means if I put 0 into h, the limit will not become undefined. Therefore, we can substitute 0 into h now. Once we substitute 0 into h, we do not write limits anymore. So it becomes 4 plus 0. So the slope will become 4. Now let's look at the right-hand side. The graph of y equals x squared is given. At the point 2, 4, there is a tangent line. Let's use rise over run to find the slope of this tangent line. So first thing is we have to find 2 points that is on this dotted line. So there's 1 point, there's another point. And we make a right triangle, which is a right triangle. And let's find the rise over run. So here, the run is positive 2 because we're going to the right. And we're going to go up by 8. That's called the rise. So we know slope equals the rise over run, changing y over changing x, which is positive 8 over positive 2. So as you can see, the slope of a tangent is at 4. Now, let's take a look at example number 2. Example number 2, the function given is a rational function, which is a fraction. So the way to do it is we are trying to combine the fractions by finding the common denominator when we use the first principles. The first thing to do is to write the first principle down again. And the next step is to substitute the value of x into the first principle. Here, the x value is 2. The next thing we do is we're trying to find out what will be f of 2 plus h and f of 2 on the side. So we know the function f(x) is 3x plus 4 over x. So first thing is we substitute 2 plus h in here. So it'll be 3 times by 2 plus h plus 4 over 2 plus h. expand the numerator and collect the like terms. After that, we find f at 2. Will be 3 times by 2 plus 4 divided by 2. That will be 10 divided by 2, which is 5. After we find the value on the side, that's substitute into the first principle. So f of 2 plus h is 10 plus 3h over 2 plus h minus f at 2, which is 5, over h. Since we have a fraction inside a fraction, we're going to change the division of h into a division sign. And numerator, there are two numbers, but we are trying to combine them into one fraction, so we have to find a common denominator, which is 2 plus h. So minus 5. 5 is 5 over 1, but I have to times by a 2 plus h in the denominator and times by a 2 plus h into the numerator and divided by h. The next step is to combine them into one single fraction. That'll be 10 plus 3h minus 5, 2 plus h, divided by h becomes times by 1 over h. Two plus h, numerator becomes 10 plus 3h minus 10 minus 5h. Times by 1 over h becomes times by h in the denominator. As you can see, numerator and denominator, they both have a factor h, so we can divide the h. Make sure you write down the restrictions. H cannot be 0. And then we're going to have limit. H is approaching to 0, negative 2 over 2 plus h. At this point, we know if we put 0 into h, the denominator does not become 0. That means we can do direct substitution. And once you put 0 into the h, you do not write limits anymore. So negative 2 plus 0 in the denominator, slope is going to be negative 1. Therefore, we say at x equals to 2, the slope of a tangent is negative 1. Let's verify it by using the graph. So fx is already given. The tangent line at x equals to 2 is also be drawn on the graph, which is a dotted line. So let's use rise over run again to find the slope. So first thing, we find 2 points that is on the dotted line that we can define clearly. So those are the 2 points. The next thing is you make a right triangle, which is a right triangle. Okay, so I'm coming from 2, 5, this point, to go to this point. That means I have to go down by 5 units. That means negative 5. And I have to go to the right by 5 units again. Because we're going to the right, we say that's positive. So slope equals to rise over run. Slope is going to be, the rise is negative 5 because we're going down. Run is positive 5 because we're going to the right. So as you can see, slope of tangent is negative 1. Example 3, the function given is a radical function now. So when we use the first principle, you're going to have a radical function in there. So how do we simplify it? We're going to use rationalization, which means we have to multiply by its conjugate. The first thing to do, again, will be writing down the first principle. Limit h is approaching to 0, f of x plus h minus f of x divided by h. Step 2, we are going to substitute the value of x into the slope of tangent, which is 7 plus h minus f of 7 divided by h. Step 3, we have to find the value on the side. So we know fx equals the square root of x minus 3. So we're going to find f of 7 plus h equals the square root of 7 plus h minus 3, which is square root of 4 plus h. And we are going to find f at 7, which is square root of 7 minus 3, which is square root of 4, which is 2. Once we find those two values, we're going to put it back into the first principle again. So square root of 4 plus h minus 2 divided by h. At this time, we know in order to simplify this, we have to multiply by its conjugate. So what will be the conjugate? The conjugate will be 4 square root of 4 plus h plus 2. But if we do this on the numerator, we have to do the same thing to the denominator. And next, we are going to expand it. But we only expand the numerator where the conjugate is and do not expand the denominator. So the numerator is a minus b times by a plus b, which is the difference of squares. So we're going to have square root of 4 plus h whole thing square minus 2 square. And we're going to have 4 plus h minus 4 divided by h, square root of 4 plus h plus 2. That's simplify the numerator. You're going to have limit, h is approaching to 0. Now you have an h left on the numerator. And you will see both numerator and denominator, they have a common factor of h. So h can be divided. Make sure you write down restrictions. H cannot be 0. And then we can write m equals the limit 1 over square root of 4 plus h plus 2. And at this time, we can think about whether or not we can put 0 into the h in the denominator. So if we put 0 into the h in the denominator, we're going to have a square root of 4 plus 0, which is square root of 4, which is 2. And 2 plus 2 is 4. So the denominator does not become 0. That means we can do direct substitution to find the limit now. So slope equals to 1 over square root of 4 plus 0 plus 2. Since we substitute the 0 into h, so there is no more limit. So 2 plus 2, slope is going to be 1 over 4. Therefore, we say the slope of tangent at x equals to 7 on this radical function will be 1 over 4. And that's checked with the graph on the right-hand side. So the function is given, and the tangent line is the dotted line. Same thing again, we're going to use rise over round to find the slope of a tangent line. Once again, the first thing is to find two clear points on the dotted line to make a right triangle, which is called a right triangle. So one point can be here, and one point can be here, and that's make a right triangle to find the rate of change. And now, let's look at this. I'm coming from this point. I have to go 1, 2, 3, 4, 5, 6, 7, 8. 8 units to the right. So say this is positive 8. That's your wrong. And the next thing we do is we're going to go 1, 2. 2 units up. That means this is positive 2. That's your rise. So we know the slope equals the rise over the wrong, which is positive 2 over positive 8. So the slope is positive 1 over 4. Therefore, the slope of tangent is at 1 over 4. So now let's make a summary. Case 1. If fx is a polynomial function like example 1, Then we expand the polynomial functions, and then we simplify. 2, just like example 2, if the fx is a rational function, which is a fraction, then we combine the fraction by finding the common denominators, and then we simplify. Case 3, if the function given is a radical function, that means there's a square root, then we multiply its conjugate to rationalize, and then we simplify.